Hello everyone, this is Ritesh from Dancing with Data. I'm former Tableau ambassador and current Power BI super user. And my name is Ritesh. Today we are going to discuss about one of the complex subject in Tableau, that is LOD functions. We'll try to make it fun with Sachin's 100. We'll try to simplify it. I hope you still remember that moment where Sachin got his 100. 100. And that's the problem statement for us today. Recently, Virat Kohli has also entered the position number 2 along with Ricky Ponting. So right in the world, he is the only man who is chasing Sachin's 100. If we start with the problem statement in the first page, we want Sachin's 100 over there, right? That number. For Ricky Ponting, it will be 71. For Virat Kohli, it will be 71 as well. So forth and so on. The problem is that because of this match type, you will have your number of centuries according to the level of detail, which is match type. Now what is level of detail? Look, it's not that tough. For any Tableau visualization, there is a virtual table that is determined by the dimension in the view. This table is not same as the tables in your data source. Especially the virtual table is determined by the dimension within the level of detail, which means dimension in on any of the following shelves or cards in a Tableau worksheet will determine the level of detail, right? In other simple words, so right now your level of detail is at year, right? It all depends on the dimensions that you are dragging and dropping to your different sections. So if you have dragged year of order date, so you get sales with respect to the year of order date. If I remove it, and if you see the block over there, not only rows and column shelves, but pages, marks, sheet. So these will determine the level of a detail. In other words, if I just put my region to color, so that will break my region into different colors. Or if I put my region into size, each region will have a particular size. Now this is based on the alphabetical order if you see the size over there, because region is of type string. So in a way you can see this the level of detail, the way you drag and drop your dimensions over there. It's a way of grouping, right? The group clause of SQL. For example, here you say select sum of sales, and you're grouping that by region over there. So something similar to that. So that's the basic definition of level of detail. But sometimes you need to go beyond the partition, the default partition that is created with the way you have dragged and dropped your dimensions over there. For example, in this case, if I want to get the average sales across all the regions, then I have to move out of this partition, right? So let's move over to the first use case over there. As you can see, our aim is to get one more column which would create a single column which would show the overall number of centuries. So for Sachin it would be 100, for Australia Ricky Ponting it should be 71, for India Virat Kohli it should be 71 again, so forth and so on. In other words, I can say I would like to exclude match type from there so I get my result. But not in this case, because I need to have match type and at the same time I need to get that number as well. But I get an idea that what to exclude. I need to exclude match type. Here is the another look at the definition. So these LOD expression give you even more control on the level of granularity you want to compute. They can be performed at a more granular level, include, or a less granular level. So we, as I said, include, exclude in this case. So we want to calculate this at a less granular level. That's why I'm removing it, right? So I need to make use of exclude function over here. That would look like this. So I will exclude my match type to get the sum of centuries, as if this column was not there. In other words, here you go. So you can see after using the exclude LOD function, I'm able to get the aggregation of these centuries over there. 171, so forth and so on. Requirement number 2. Can we get aggregate centuries for each country? So for example, in India we have Sachin, Virat and we have Rahul as well. So the aggregation with exclude, we know the aggregation of centuries for these three players. But if I want to aggregate this at country level, so when you say at country level, maybe I can say that I want to fix my number of centuries with respect to country. So I'll make use of fixed LOD function. This is the syntax.
And remember, if you want to know more about the syntax, you can always go over there and it will give you example as well over there. It's simple. You can have even zero over there. Actually, you can have zero or more number of dimensions over there. So you can fix it at any point of time. Okay, let us go and see if we get the solution or not. Here you go. So it says for the country Australia it's 71, for India it's 219. So let us check. For India it's Virat 71, 100 Sachin 171 plus 48. That is exactly 290. So that's the example of fixed. Last but not the least, what about include over there? Well, include is just opposite of exclude. That means you are going at more granular level. So in this case, I want to get the average centuries per player within a country. For example, within Australia, you have only one person, so 71 divided by 1, that would remain 71. But for India, it should be 219 divided by 3. So I get the average per person within a country. So I'm going more granular in this case. So I will make use of include function over there. Include name, sum of centuries, so forth and so on. So if I just pick it over there, here you go. 71 divided by 1, that remains same. But here, oh, one more thing that you need not to forget, that once you have done this thing, we need to get the average, right? We are talking about average, so we need to turn this to average. Here you go, 71 divided by 1, 71. India, 219 divided by 3, so 73. South Africa, so how many players over there we can see? Okay, South AB de Villiers and Jack Callis. I think we have two players over there. So if you divide this by, no, I think there are three players over there. Yeah, so we have Hashim Amla as well, Jack Callis. So divided by 3, fair enough. So if you divide this by 3, you get 54.66. So I hope this beginner video on LOD function was useful and informative and it did not overload you. This is the time, if you like the video, press hit the like button, and always welcome you to write anything about this video, any feedback, it will be highly appreciated, or a new video topic that you want to suggest. At the end, subscribe to this channel if the videos are making sense to you. So this is Ritesh signing off from Dancing with Data. Remember, a fan of data should know how to have fun with data. So do have fun with data. This is Ritesh signing off. Bye bye.